Good evening. Good evening, sir. My name is Christopher Rebecca Boni. Section S2I. Course Base MT. Radar X-band and radar S-band. Simply put, they difference frequency. The majority of marine radars operate on X-band. X-band is widely used because of the ability to utilize smaller antennas that fit on most boats and to provide better target resolution. S-band radars are often used for specialized applications such as seeing through heavy weather or precipitation and for long-range bird detections. S-band antennas are larger. The smallest Furano S-band antennas is 9 feet long and can be as long as 12 feet. ABL control. ABL is an acronym for electronic bearing line. It is used to determine the bearing from your present location to a specific target. Use the ABL function to bisect the target and see its bearing in the ABL readout display. Brilliance control. Brilliant replaces any standard light switch and comes in 4 models to fit any standard electrical box. Single to 4 switch box, no custom wiring modification or hubs required. Brilliant also turns standard lights into smart light that you are control with a simple voice, command, tap, or motion. AC rain control. Adjust AC rain control using rain clutter. The vertical bandwidth of the antenna is designed to see surface targets even the ship is rolling. However, by this design, the unit will also detect rain clutter, rain, snow, hail, etc. In the same manner as normal targets, figure 2-5 shows the appearance of rain clutter on the display. Adjusting rain clutter mask equals adjust the AC rain control. This control splits up the bandwidth equals into a speckled pattern, making a recognition of solid target easier. Adjusting the ACC control. ACC control. The proper setting of the ACC should be such that the clutter is broken up into small dots and small targets become distinguishable. If the control is too low, targets will be hidden in the clutter, while if it is too high, both clutter and targets will disappear from the display. In most cases, adjust the control anti-clutter has disappeared to leeward but a little still visible in windward. Confirm that the visibility is properly adjusted and transmit on the short range to adjust the AC control so small targets are distinguishable but some clutter remains on the display. Gain control. Gain control is necessary to adjust the receiver sensitivity for the best reception of the signals widely varying amplitudes. A complex from automatic gain control, AGC or instantaneous automatic gain control, is used during normal operations. Range K. The other radar can use a short range scale which helps to detect smaller targets easily. Use the range key in the keyboard to select the range desired. The plus key increase the range where the D decrease the range. VRM. The VRM variable range marker measures the range to targets. To measure range, press the key to display the VRM. It appears as a dash circle. Adjust the VRM so that if it touches the inner edge of the target. Tune. The tune control is used to tune the receiver in the radar antenna for maximum target returns on the display. The radar comes from the factory already tuned, so this operation is not necessary at first installation. In general radar tuning may be necessary in the radar antenna was service. Course up. In a course up established display, the heading marker is aligned to 00 on the fixed scale at an instant at which vessel is right on the course due to azimuth stabilization changes. In the vessel's course doesn't change the heading marker and maintain the ship's course aligned to the 0 of the fixed bearing scale. Head up. In head up mode, the up direction of the display represents the vessel's heading. In course up mode, it represents the directions which has been input as the vessel's desired course. North up. A radar display with an True north 00 remains at the top of the radar screen regardless of your vessel's heading. Your own heading is marked on the screen with a heading line oriented toward your actual course. The display requires a heading sensor input the radar. True motions. True motion radar displays on shapes and moving objects in their true motions, unlike relative motion radar. On shapes position is not fixed on the PPI. On shapes and the other moving objects move on the PPI in according with their true courses and speeds. Relative motion, the last. The relative motion display portrays the motion of a target relative to the motions of the observing ship. The true motion display portrays the actual or true motions of the target and the observing ships. That's all.